Hey everybody, welcome to this edition of the Microchip live stream. As always, we're broadcasting live from our corporate headquarters here in Chandler, Arizona. This is your opportunity to interact with us, talk to some engineers about today's topic, which is going to be about IoT applications, specifically with regards to horticulture. Joining me in the studio, we have a couple of gentlemen here. The first is Mr. Raymond Yin from Mouser. And the second is Mr. Lakshan Dias. He's with a company called Medium One. And we'll talk a little bit more with these gentlemen. First, we're going to send it off to the booth and have Clifford and Wayne tell us about how you can interact with us.
Thank you very much, Mark. My name is Clifford Swartz, and to
I'm
your right,
Wayne. Oh.
I have Wayne Freeman, my boss. Sorry for speaking over you.
No, I'm not your boss.
This is our first live stream of the new year, the new decade. We're very excited to be here. We got some new things. We have a new desk, new mics, and I think we're doing something new with audience participation.
Yeah, absolutely. We have, let's say, a change in our in our giveaway rules that's going into effect. So we're gonna have to play it by ear with all you folks out here in YouTube land. But basically, we have an awesome number of giveaways today. We're actually going to do PIC-IoT boards. So we have 20 PIC-IoT boards, and Lakshan is going to tell you more about Medium One and what they offer as a service. He's going to give away some free free one-year subscriptions to a particular portion of their particular service that they offer, and the good folks at Mouser will also be contributing some swag as well. So I'll explain it a little later, but what we're going to do is we're going to have a survey that I'm going to post the link in the comments, and we'll probably put it in the description near the end of the show. The first 20 participants, first 20 of you guys who fill out that survey will be eligible for basically getting one of these prizes. So the first 5 will get the whole package, which includes the Medium One subscription. The last 15 will get PIC-IoT boards and swag from Mouser. We haven't identified what that's going to be just yet, but it's going to be really cool. It'll be very cool. So hopefully I've explained that correctly. I don't know, Clifford, what do you think?
I think you did a fine job. We're going to revisit later, too.
All right.
So that's different, but what is always going to be the same is if you want to ask any questions, feel free to post it in the comments, and we'll have our experts answer live. And if we don't get to it, feel free to email us at livestream@microchip.com.
Yes, Clifford will answer your questions personally.
Directly, absolutely. I think that's all we have, but back to you, Mark.
Okay. And we're going to have folks answering questions in the chat as well. Is that correct?
Yes.
That's correct.
Okay. All right, so if your question doesn't get on the live stream here, please ask it. As Clifford said, we'll get back to you later, or in the chat. Okay. So today we're talking about IoT, and we're going to talk specifically about a horticulture application. However, if you're interested in doing some sort of IoT application, a lot of these things that we're going to discuss are going to be very applicable to you. So please stay with us. I'm sure we'll have something that covers something you want to do with an IoT application. To that end, let's introduce our guests today. First, let's talk to Mr. Raymond Yin. Raymond, you're with Mouser.
Yep.
Can you tell us a little bit about yourself? Tell us about Mouser.
So Mouser, we are a global distributor of semiconductors and electronic components, and we specialize in the rapid introduction of new products and new technologies to design engineers and buyers.
Okay.
And me personally, I am responsible for our technical content, which includes all of our white papers, our blog, our various ebooks, and of course, like today, we're talking about our projects.
Excellent.
And we have over 1,100 pieces of content available on Mouser.com.
That's awesome. And Mouser has developed a really nice partnership with Microchip. Can you talk a little bit about that?
Sure. Yeah, we're obviously one of your distributors. Otherwise, I probably wouldn't be here. But beyond that, we actually have more Microchip product in stock, ready for delivery than anyone else on the planet. And we also partner on various projects. Our Empowering Innovation project, we partnered to talk about the journey from innovation to productization to our mutual customers.
Okay.
And beyond that, we've done design contests, trade shows, and various other projects and things like that.
And Mauser's a great spot if you want to have like a one-stop shop for things like development boards, the components that we'll talk about today.
Absolutely.
Cool. And Lakshan, welcome. Lakshan's with a company called Medium One. Can you talk a little bit about Medium One and when you were founded, where you're located, and what you guys do?
Sure, absolutely. I'm a co-founder and head of platform development at Medium One, and we were founded in 2014. We're in Silicon Valley, founded there and headquartered there. And what Medium One does is help IoT developers bring their applications to life.
Okay.
We provide a very flexible cloud backend, as well as offering a front end, a very customizable front end for the end customer.
Okay. And did you want to show your slide, or is that?
Yeah, if we could.
Yeah, just to kind of explain a little more.
Yeah. So, and what we're going to talk about today in the Smart Agriculture projects that Raymond mentioned, we've brought together with Mauser, with Microchip, we have the end-to-end solution for an IoT developer. You have the hardware, in this case I've shown here the PIC-IoT, with your connectivity to a flexible white label cloud backend, along with what we provide native mobile apps and a portal for your end customers.
And what does that mean, white label?
White label meaning you can brand it yourself.
Okay.
And that's just the very minimum. It's very flexible and customizable beyond just the branding.
Okay. So if you have an IoT application and your next step is you've developed the hardware, you've developed the application, now you want to connect to the cloud, these are the folks you want to come and see if you need to get connected, correct?
Yes.
Okay, awesome. So let's talk a little bit about the application today. So we're dealing with a horticultural application, and I have a kind of an overview slide. If you guys want to go to my computer here for a sec, I'll pull it up. And just, so basically this is in essence what we're dealing with. So we have an agricultural application, so there's plants, and we're connecting to a sensor, and then we're going to take that sensor information, pass it to a microcontroller, and then that microcontroller is going to communicate with the cloud. And that communication, as Lakshan mentioned, is going to happen over the PIC-IoT board, and we'll look into that in a little more depth. And then the processing is, a good portion of processing is going to take place in the cloud. Now, to that end, this is a one-way communication, but if we go back to the slide, you can see that we can also do some other things here, and we can have back and forth communication in which the cloud or the engine on the cloud could have some response dynamically to system changes and make changes themselves. And you can see here it communicates back through the IoT board to the microcontroller and then maybe to an actuator or a motor. Okay? Raymond, can you talk a little bit about how we came up with this application? Where did the idea come from?
So a couple of years ago, we did an ebook on vertical farming. And smart agriculture, vertical farming, those concepts are becoming much more important as the global population approaches 10 billion, which is projected to do around 2050.
Okay.
With about 70%-ish living in urban areas. And so putting the food production and whatnot in the areas where people are living is going to be very, very important. And realizing that most of us don't need to harvest 10,000 heads of lettuce in a day.
Right.
We took that concept of vertical farming and brought it down into horticulture so that everybody can participate.
That's awesome. And you can't get any more organic than growing your own food.
Absolutely.
Yeah, you know what's going into it. So how did your relationship develop with Medium One?
So Looking at our portfolio, we recognize that we wanted a solid partner for cloud services in that side of the development, and we've had a great partnership with Medium One for a couple of years. They've got a very similar philosophy to Mouser in regards to providing great service to the design engineer in that prototyping and proof of concept phase.
Okay.
So it's been a great relationship for the last couple of years.
So this application, it demonstrates an IoT application, but it also highlights each individual company's kind of value adds to this. Can you maybe talk a little bit, Lakshan, about how Medium One comes into play with all this?
Sure. Yeah, as Raymond said, one of the things that we do is really help design engineers in the prototyping or proof of concept phase, which is great for this project demonstrating a horticulture application. We help design engineers by consulting with them, and like the subscriptions that will be given away later, you get 1-year access to our Sandbox environment, which is a great place to start sending data and getting a chance to look at it and start testing out some of your assumptions, some of your theories on that data.
Very cool. Okay, so why don't we go to the Mouser website, Raymond, and let's take a look at how somebody would find this application first of all.
Okay. So the main hub for all of our technical content is under the technical resources on the top navigation bar.
Okay.
So clicking there, this kind of shows an example of what we have available for engineers to learn about new technologies, to look at new products, between white papers and our blog and our ebooks. So Mark, if you could go ahead and type horticulture into the search engine. This is a content search engine, unlike the main search engine on Mouser, which is searching for products.
Okay.
So, once you're there, you're able to bring up, all the different technical resources that we have available for horticulture, including the various project articles that we're going to talk about today.
Okay. And this particular article, I would find it here?
Under the article section, correct. You're in the horticulture application site.
Okay.
And once again, this is the hub for horticulture content. And if you go to the articles, under horticulture, yeah, you'll be able to see the various. I think you're on the irrigation one.
Okay, I think I got that one open here. Is this the one?
I can't see here. Yeah, but
I think it is.
I think it is.
Okay.
So what you'll find here is an explanation of the project itself. And for this particular project for horticulture, as part of the research, we actually reached out to the students and faculty at North Carolina State University.
Oh, cool.
Yeah, well, they've got a great horticulture program. They're experts in the area, and they really kind of helped educate us on the plant side, the natural side of horticulture. And we took that information back, created the project, and in the article you'll be able to see kind of the background material. You'll be able to see some of our design philosophy and why we chose certain products. And in addition to all the software and the materials that are required to complete the project.
And you have a bill of materials here.
Yep.
And an estimated cost. That's cool.
Yep. And as part of the bill of materials, we include the 1-year subscription to Medium One.
Okay. So with regards to the application, can you talk a bit about the design process that happened with this?
Yeah. After we talked to the folks at the university, we looked at, that kind of drove us to a certain group of sensors that we would require for the measurement piece of it.
Okay.
And what we did then was we broke up the overall application into 3 parts. There is the sensor and measurement piece. There's the lighting piece because plants respond differently to different wavelengths of light. And sometimes it needs to be brighter, dimmer, whatever it may be. So there's a lighting control piece. And then finally there's the irrigation piece, where we control motors and actuators to maintain a certain level of moisture in the soil.
Okay. Now Lakshan, there is an interface to measure the data coming out of this. Did you want to show that?
Sure. Let's take a look at that. So this is our cloud backend. The developer will log in and see this site. And the data we're actually going to look at is coming from a PIC-IoT, although it's not the the application that we've seen the articles for. This device, let's take a look at the dashboard. This device is just sending us data from a light sensor and a temperature sensor right now. This is temperature in Celsius, 30 degrees, it's kind of hot. I believe this is Dallas. This is in Dallas.
Wow.
So these are some of the widgets that you can use to visualize the data on our back end. We have the real-time gauges, a line chart here, and down here we're actually seeing the raw data come in. This is part of the flexibility of our cloud platform. The devices will send in JSON, so it is arbitrary, the data that can be sent. You can send in any key value pair. And from there, we can go on to build lots of cool business logic, take actions, and I'm going to show you one of those right now in our workflow studio. So our workflow engine has the capability to process every single event that comes in. So a simple example I want to show today is simply converting the Celsius to Fahrenheit. So this workflow uses a combination of visual design as well as code.
Nice.
What you see here is the raw Celsius temperature coming in, and it's going to trigger this Python code to run. And hopefully everybody can see it. I'll try to zoom in a little more. All I'm really doing is taking that input value and multiplying by 9/5 and adding 32, which if my math is correct will give us Fahrenheit. So let me just activate this again. I'll take us back to the dashboard. Zoom out a little bit. And let's take a look at that real-time stream. So now you can see there's a new value coming in. I didn't take the time to name it, but you can see this processed value is 87.
Okay.
That's the Fahrenheit temperature. And that's just a quick peek at what our cloud can do.
That's very cool. So now if a customer comes in and has no experience with this, this is where you guys are, this is your thing. So you guys can handhold a customer through this entire process.
Absolutely. We definitely offer consulting services. On top of that, we have a lot of template code, a lot of reusable workflows, reusable dashboards, and what I mentioned earlier about our customer-facing portal and mobile apps. We have a lot of that boilerplate done and ready for the design engineer to build out the way they envision.
Very cool. So Raymond, we talked a little bit about the sensors, and you can see that we have a temperature, humidity, moisture content, pH.
Right.
So some of the considerations that needed to be taken whenever we were discussing sensors. Can you talk a little bit about some of the aspects that you would need to take care of on the microcontroller side? So anything related to the sensors that the microcontroller had to do.
Right. So yeah, the microcontroller really is taking all the sensor data and creating a conduit to the cloud service. And the main part of the interface to the sensor is what exactly is that interface? Is it an I2C? Is it a digital interface or is it an analog interface? And in this particular project, it turns out it's both. And so we were looking for a microcontroller that had both an I2C interface and yet also had onboard analog to take into the analog output of a couple of these sensors.
Very cool. And just for viewers, we do have Microchip really focuses especially with our 8 and 16-bit products, on heavy analog integration. I think we have a question.
Yes, we do. So we have people interested in LoRa and how that interfaces with what you guys are talking about. But in addition to that, I'd like to give a shout out to Jared and Daniel. Thank you very much for your participation. And if you guys have any other questions, just drop them below.
Also, thanks to Luis and everybody who's basically said hello to us. Just wanted to say hi. But yeah, so we have a lot of activity, and I wanted to remind you guys. We have Lakshan is for Medium 1. If you have any questions about their service, go ahead and shoot them in the chat. If you have any questions about the stuff that Mouser can offer, go ahead and send that in the chat, and we'll get it out to Raymond and Lakshan. So this is a great opportunity.
So Raymond, perhaps you could talk a little bit about the LoRa connectivity. I mean, for viewers who don't know what it is, maybe we should explain what it is first of all.
Yeah, another main consideration in any IoT system is the connectivity, and for most it's going to be some sort of wireless. And really, what you have to look at is the amount of data that you're going to send, how far do you want to send it, and really, and the overall cost of the end cost of the system in general. For this particular project, we chose Wi-Fi since a horticulture greenhouse type of layout. We're not talking a whole lot of geographical area that we need to cover.
Right, so you could probably have like a router or something.
Yeah, exactly.
Really close by.
Exactly. However, if somebody wanted to take the sensor portion of this and put it out in a field somewhere, out on a farm, out of range of any Wi-Fi, LoRa would be an excellent excellent solution for the wireless connectivity. Okay. LoRa is very low power. It tends to be very low bit rate. So you're not transmitting a lot of data. You're just transferring, every once in a while, transmitting sensor data up to the cloud, up to Medium 1 for processing. And one of the advantages of LoRa, you can actually create private LoRa networks, so you're not paying a carrier or anything like that for using their service.
Okay. And Lakshan, does that make any difference with your end of the application, which connectivity method they choose?
No, to our end, it doesn't make a difference as long as you have internet connectivity and you can talk one of the protocols we support, okay. MQTT, REST, or WebSockets. Okay. Then you can get the data to us. But I think it is important to mention the data model, okay. How you structure the data, how frequently you send the data, and especially what kind of processing you'll do on the edge or the microcontroller before you get to the cloud. Okay. Because you have other budgets to consider. With Medium 1, you have, we meter by events. Mm-hmm. So what you're paying for is the total amount of data you can store and the workflows you can run on it. But you'll have other budgets to consider, like your network budget going to the internet, your network bandwidth between the sensors and the microcontroller, like over LoRa or Bluetooth. Especially if your internet connection is cellular, you have a cellular data budget as well. So a lot of things to consider.
Okay, and Microchip sells a wide variety of microcontrollers, everything from very small, inexpensive, tiny 8-bit devices up to very high-end, really nice 32-bit processors. So with regards to that budget, you may have to take into consideration things like low power. You're going to take into consideration how fast things are being processed. So depending on the application, I mean, in this application, Raymond, we're using an 8-bit device.
Correct.
And we're connecting to the PIC-IoT board, which is a 16-bit device. And both those devices have individual capabilities. But if you need to keep that device in low power sleep mode for, especially if it's a battery-based node, then perhaps you can send a stream of data and then offload that processing to the cloud. And this is where Medium 1 comes in. Cool. So with regards to the sensors, again, you talked a little bit about the I2C, so serial communications. You talked a little bit about the analog integration. What about robustness? Was that a factor at all? I know this is a device that is capable, and I'll pull up the device shortly. This is a device that's capable of operating at 5 volts. Mm-hmm. Can you talk a little bit about if that was an important factor? Or?
In this particular case, it really wasn't. Okay. One of the factors that did influence our processor choice was simply familiarity. I mean, we chose for this particular application an ATmega 328, which a lot of people are familiar with. That is the microcontroller that's found on the Arduino Uno.
Right.
And there wasn't a specific requirement for low power since we were in close proximity to power, and and same with the voltage. It wasn't a specific requirement in this particular case. However, as you mentioned, Mark, I mean, if it were a remote application, if it were something sitting in a field, power would be a major consideration. Mm-hmm. In which case, we would probably chosen another one of the 8-bit PICs that had the various low power modes.
Okay, and then as far as the 5-volt aspect of it goes, if we're dealing with an IoT application that is industrial based, there's some environmental things that we need to take care of. So noise being one of them, and 5 volts can help with that, pulling, giving you a little more bandwidth as far as reading in and attenuating noise or taking noise out of consideration.
It's a little bit. It tends to be a little bit more immune to electrical noise than a lower supply voltage.
Right. Okay. Now, just for our viewers to take a look at the board that we're using on that page on the Mouser website, you'll see here again. There's a bill of materials, and each one is a link. And I've already taken the liberty to open the link for that board. The board we're talking about here is the ATmega 328PB, and this is an explained mini board. And what that means is that this board has the capability to integrate a programmer debugger. It also has, and this isn't too noticeable, but if you look on either side, as Raymond mentioned, these are the devices that take that are used on the Arduino boards, and there is connectivity for Arduino-style shields. Just as a side note, I wanted to bring up a different type of board as well that Microchip has recently introduced in these. And if you've watched the live streams in the past, you may be familiar with this. These are called Curiosity Nanos, and these are also available on Mouser's homepage in their products that you can select from. But these are essentially kind of similar. They have a programmer debugger on them, but they also have connectivity to all the pins, and the boards are a little smaller. In fact, we kind of nicknamed them gum stick boards around here, but just because they look like a stick of gum. But anyway, I digress. So let's talk a bit about the development software. How did how was the application developed? What code did you, or what platform IDE did you use?
So the initial project was developed using Atmel Studio.
Okay.
However, we have since gone in and redeveloped it and upgraded it to use MPLAB.
Okay.
Which is the newer development system, and we actually are working on a video to show customers how to take existing projects in Atmel Studio and convert them over to MPLAB. Some of the things they've got to change, some of the kind of the gotchas that they need to be watching out for.
Very cool. And just as a general information, Studio 7 isn't going away anytime soon. If that is the platform you want to use and continue to use, it's still there. But as Raymond mentioned, we are moving AVRs into MPLABX more and more, where you can take advantage of certain tools like the IDE itself, the debugger, and the MPLAB code configurator to keep it high level when you're developing applications. I think we have a question.
Yes, we do.
Yeah, we actually have several questions. So
nice.
Thank you all for responding to
That's great.
our call here. They kind of they focus around kind of two kind of distinct aspects. One of which relates to the hardware. The other one seems to relate to the compatibility of the Medium 1 platform to accepting various data streams. So let's see. I'll start with kind of questions for Lakshan. So I'm going to put you on the spot here. Sure. So the first question is from Juan. He wants to know where he can find info about the kind of the cost in terms of like data per month. Do you have that kind of readily posted somewhere on Medium 1 site, or do you have different plans that you offer?
We do have our starting plan. You can find the pricing information on our website, which will include the number of events that you can send per day.
And that's medium1.com.
I have the website open here if you
perfect.
want
Yeah, if you can
go
take
to
a look.
Yeah.
Yeah, so you can go to that button at the top to get a quote. You'll fill in some information about your proof of concept, and we'll come back with an estimated event budget and what it's going to cost per month. And again, we meter events per day. And an event is that JSON object that we were looking at earlier, which can contain any number of key value pairs. If you're looking for a larger scale project, if you're beyond perhaps the prototyping or proof of concept phase, or even if you have a finished product and you're ready to take it to production and you need that scale, we can help you with that. And just contact us to consult with us. I just wanted to mention again that while we do greatly accelerate the prototyping phase, our cloud is flexible and scalable enough to take you all the way to production.
That's perfect. The other question is kind of a simple one. Is this platform LoRa friendly? And I can answer that question, but I can let you, elaborate if you want.
Is that for me?
Yeah, that's for you.
Okay. Yeah, referring to Medium 1, actually, Mark asked something similar before. We are really agnostic to the wireless protocols that are being used. Specifically, if we're talking about LoRa, you're going to have your end node sensor is going to be talking to some kind of LoRa termination, a LoRa gateway or a microcontroller that's also speaking LoRa. So it's really the uplink from that microcontroller to Medium 1 over the internet. That's where we talk about our protocols that we support, MQTT, REST, WebSockets.
Okay, perfect. So I'm going to take you off the hot seat now.
All right.
Like I said, I have like a notepad full of questions here because I'm old and this is how I store data.
Yeah. For our younger viewers, that's called paper.
But so the next line of questioning, so Juan and Daniel actually asked some pretty good questions around powering such an edge node solution. So Juan wanted to kind of get an understanding about how you supply power to the device. And I think Daniel kind of asked a bit more of a pointed question that we can speak to kind of the low power aspects of our products, our 8 and 16-bit PIC and AVR MCUs, where the question is there an energy harvesting option to power the devices like water or solar? So this is probably more for you, Mark, but
okay. With regards to low power aspects, there's a lot of different options. It's going to depend on the application. First of all, there is a movement within Microchip to integrate as much as we can onto the device. So things, as Raymond mentioned, integrated analog, but also other components or other peripherals that kind of take the load off the central processing unit, and they're called core independent peripherals. And what if you've watched previous live streams before, we've mentioned this. But essentially what happens is you're taking something off of the central processing unit and putting it on the hardware. So something that can accommodate a simple task, but it's done in hardware. Oftentimes, these tasks can be handled by the hardware while the device is in a lower power mode. And we have many different versions of these low power modes where you can balance performance versus power consumption. So you can either put the CPU to sleep while keeping the peripherals alive if you need a clock source for that, or if you're in the case of an analog solution, you can put the device into sleep mode, and a lot of the analog products will work while the device is in sleep mode. In fact, that's a good way to do analog to digital converter readings. If you shut off all the clocks, except for this one clock for the A to D, that actually gives you less noise in the system. Other low power aspects are just across the board. You can do that balance where you shut off the CPU, you can shut off the clocks to the device. You can actually use peripherals or peripheral capabilities that completely, we have a peripheral module disable, which actually stops things like clock signals from banging up against something that's not responding, and it kind of keeps it into a lower power mode. So there's lots of options available. If you need to process information faster and it's very math intensive, you can do that with some of the higher end devices as you get into DS-PICs or into PIC-32s that can operate a lot faster and allow you to get back into that lower power mode. And then again, if you're set on using the 8-bit characteristics or 16-bit, but you want to do some heavy processing, the cloud, things like Medium 1 services can come into play at that point. Does that answer the question?
I think it does. I think you've done an awesome job. All right, thank you. Didn't want to derail you too much, but no. We had lots of great questions, and they're still coming in. So I'll probably derail you again after this segment.
Please. Okay.
If I could just actually add on to that.
Please.
We have some customers in the health vertical, and in this particular case, the customer is using sensors and communicating the sensor data over Bluetooth to a microcontroller. And one of the sensors is an accelerometer. And so this acceleration data is coming in very quickly, and usually that has to be the case, because if you want to see if an impact has occurred, you need to look at a lot of accelerometer data in a very short interval to look for things like impulses and that kind of thing. And if you were to send every single one of those events to the cloud, you would be burning power on the network connection,
Right.
whether it's cellular or wireless or even Ethernet. You're still consuming power there, as well as the data budget. So this customer aggregates a lot of that data. They do a lot of statistics like averaging, standard deviation, and all of that on the accelerometer data, and then they just send one aggregated result to the cloud. So that's a very common use case for us in a lot of verticals.
And that's Bluetooth. That's a very short, that's a very close connection. Like you're talking feet to meters.
Yeah.
Whereas LoRa, you're talking what,
Kilometers.
kilometers.
potentially.
Yeah. So everywhere in between in that interface is totally doable with the medium one stuff. Talking about connectivity, the way we're taking that information, so we're taking the sensor data, putting it onto the Mega 328P, and then sending content over to the PIC-IoT board. Raymond, can you talk a little bit about that platform or what that thing's doing in the application?
Yeah, sure. The PIC-IoT was specifically designed to maintain IoT connectivity, and it's a great tool for for pushing information to the cloud. It's got we've done several projects around the PIC-IoT, to connect to various services, obviously including Medium One, and the example that we're showing is one of our PIC-IoT projects talking to Medium One.
Okay.
So it's a great gateway. It's a great conduit to use just for any type of internet connectivity.
Okay. And if we could go back to my computer screen, I've actually got the Mouser page open for the PIC-IoT board. It's a little, let me zoom in a bit, but I'll enlarge the image here. So this is the board that we're talking about. You can see here, down here again, we have that programmer debugger on there. Over here is the target device, which is a PIC-24, which is one of our 16-bit devices. And these guys have a lot of analog on them too. There's some sensors here. We have a microchip temperature sensor. We also have an encryption chip over here and one of Microchip's Wi-Fi modules. So a very tiny board. There's connectivity up here for microelectronica clicks. So for example, if you had one of these Bluetooth applications, you could literally have a BLE board or a Bluetooth board connected here from microelectronica, receive information perhaps from an 8-bit device somewhere on a wearable or a remote node, and then this board can be used then to transmit that information to the cloud.
In fact, we are actually using a micro LoRa click board to get that LoRa connectivity for our long-range project.
Very cool. Yeah, it's the ecosystem there with the clickboards. There's over 700 of these boards, and there are more coming out every day. But the goal here is to make prototyping as easy as possible and minimize breadboarding, while still being able to evaluate a lot of these applications from your desk actually.
Right. Yeah, it's great for all kinds of expansion, be it connectivity, be it sensors, displays. Yeah, they've also been a great partner for us as well.
Very cool. Now, Lakshan, so I'm not sure if you covered this already, but can we take a look at the web portal? Go into a little more depth with that? Or?
Yeah, absolutely. We can dive in a little more. All right, so back on the dashboard, we still see some data flowing in. It looks like the PIC-IoT in Dallas is sending data every 5 to 10 seconds or so.
Is it still hot?
Let's see. in Fahrenheit 89, if I'm reading that
It's getting
correctly.
warmer.
Yeah, that's not bad.
So, as I mentioned before, we have several widgets here, different ways for you to visualize your data. And in that prototyping and proof of concept phase, you're exploring your data. You're trying to find patterns, trends, or validate an assumption about what you're building. The Workflow Studio we took a quick look at. This is where you can build really complex business logic, leveraging Python and the visual design engine.
And Python is becoming kind of almost an industry standard these days, isn't it?
Oh yeah, it's a great language, very easy to learn.
Yeah.
Not completely functional, still a bit procedural, so it sits well in both camps. Very powerful, flexible language. Yeah, that is why we chose it.
Okay. Now, talking about new users, we touched a little bit on this. But again, I've never developed a cloud-based interface before. What are my options?
Well, you're in the right place. Just to reiterate what I said at the beginning, this project really shows how Medium One, Mouser, and Microchip are providing an end-to-end solution. So you don't even have to really worry about the cloud. The path that we want most developers to take is envision your final product. Envision what it's going to look like to your customer, how you're going to communicate with your customer, if you're going to send text messages when something goes wrong or maybe when something goes right. What kind of reports are you going to be sending? Are you going to email some reports showing a return on investment? Those are the things we want the developer to focus on. We take care of the cloud for you.
Very cool.
It's a hosted cloud. You don't have to worry about building your own servers, maintaining them, security. We handle all of that for you, and especially scale.
And when should a developer of an application get in touch with you? At what point is best?
Good question. If we could go to my slide one more time. Really, the earlier the better in the journey. But we definitely have customers who have built, let's call it an offline product. They've built some cool hardware. It solves a great problem. And now they want to connect it to the cloud. So we've been brought in at that phase. We've been brought in before any hardware was bought. We can help at all stages, really.
Okay.
We can accelerate your prototyping phase or proof of concept, just making that path faster from getting the sensor data to the cloud, processed in some way, and start learning from it.
And sorry, Raymond, did you have a?
Yeah, I just wanted to interject that, one of the things that we found working with Medium One is just the absolute ease of use of their system, of, working with the engineers there. As an example, years ago, we, one of our first IoT projects, we worked with Microsoft Azure. Great service. And as we, put down our credit card and open our account, they were spinning up 13 servers, giving us petabytes of storage. So on, and we were just all we want to do is stream some sensor data, and so and that's one of the reasons Medium One is at that prototyping phase for engineers. I mean, and just from our experience, is a much easier path to go.
And you guys may be able to provide some level of optimization for the application if they come to you early on.
Yeah, exactly. Like we talked about the data model before, we have a lot of experience there, so
Okay.
we always offer our feedback.
Now, speaking about support, next steps, that kind of thing. So for Mouser, so somebody wants to get up and running, they have an idea for an IoT application. What would your recommendation be for their next steps?
So, for us, it's they can come to the site and come to Mouser.com and just search on whatever technology that they're interested in. If it's going to be a smart home project or an agriculture project or maybe even an industrial project. I mean, we've got content available for engineers to read up on the latest specifications, the latest standards, and then to really see some of the the projects that we've done. And then finally, to be able to actually buy the product.
Mm-hmm. And as I said, it's a one-stop shop. So you're saving money just on like bundling everything together.
Right. Right. And, one big box instead of a bunch of little ones.
Yeah, yeah, and paying a separate shipping charge for it.
Exactly.
What about with Medium 1, Lakshan?
Yeah, we always recommend developers to come and consult with us. Just send us an email. You'll have the contact info at the end.
Yeah.
We're always available to consult on any size project.
Okay. And then from a Microchip perspective, as you get into the product, it's specifically with the embedded products, so the microcontroller or some of the development boards. If you head over to microchip.com/support, there's all sorts of technical support places that we can connect you with. So whether it's a forum, whether you need to get a ticket log to talk to one of our customer applications engineers, or if there's some content online in the form of a tech brief, an app note, or even our developer wiki, which is a great resource to go in and see some examples. Cool. Is there anything from the booth, guys? We have, I think that's pretty much everything.
So actually, I think that's going to be it. It looks like a few of our moderators we see that the Mauser folks are also online in the chat, getting questions answered. I'm going to see if I can. I'll throw one last one out at you. This is also for Lakshan. Is there a free demo that someone can use to kind of test out the platform before they have to put in a credit card to pay?
Not today.
All right, cool.
Not currently. Your best bet is to go to Mauser and get the subscription. I believe it's $75.
It's a very good deal because that lasts an entire year. Correct?
Yep, that's right.
Perfect.
And where's the link going to be for this? Will this be in the description area below the video, or?
Yeah, we'll put the links in the description. Okay. So the other thing is I guess that brings us to our giveaway plan, and I apologize for the fact that we're kind of making changes to the plan here. We are. We're no longer going to be able to choose winners from the chat randomly. So that's why we have the survey in place. I'm going to drop a link to the survey. Actually, Kurt's going to drop a link to the survey right now. The first 20 people who respond to that survey will get in contact with you. The first 5 of those 20 will get actually that $75 value 1-year subscription to the Medium 1 Sandbox, and a PIC-IoT and some swag from Mauser. The remaining 15 will get the PIC-IoT and swag from Mauser. Does that sound?
I think
sound like I got it.
Yeah.
Because I'm still formulating it anyway. So survey link should be dropped. Once again, this is something. This is kind of a new way we're testing out. If this doesn't quite work out for you guys, we'll move to something else. But we need to make sure that we keep our all parties, all of our legal entities happy here. At Microchip and Mauser and Medium 1. So it involves the survey involves you giving consent to provide your basically your email address to Mauser and Medium 1, so we can provide you with the free swag. That's pretty much it.
Yeah.
Any other housekeeping things we have to do?
So, as always, if you guys want to keep in touch with us, you can email us at livestream@microchip.com. If you want to know whenever we're going live, make sure to subscribe and hit the bell so you actually get a little ping on your phone or whatever device you're using. And thanks for tuning in.
Yeah. Do you know what's going on next month for next month's live stream?
I don't know.
Oh, so it's very cool. I knew you didn't know.
Okay.
But it's going to be a really awesome live stream from our from one of our analog business units. They're going to be talking about the Mindy tool that we have on offer here at Microchip. It's basically a free tool you can use to help develop your analog circuitry. And I'm not going to profess to be an analog expert, so I'm going to be very interested in watching it myself. I think that's February 26th, if I'm not mistaken, but don't hold me to that. I think there's already a card up for it on the YouTube channel. Come back for that. That's going to be awesome.
Absolutely.
All right, we're going to throw it back to you guys on the stage there and take it home for us.
Very cool. Well, Raymond, Lakshan, it was a pleasure meeting you guys.
Thank you.
I
Thanks for
definitely
having
learned
us.
a lot. Everybody, again, the chat's still up. If you want to ask a question, if you want to, take advantage of that, or if you want to send us an email, as Clifford said. Other than that, thank you so much for joining us, and we'll see you next time.